Okay, today we're talking about exponential functions, and it has a general form, and it's y equals ab to the x. And a is going to be your initial value. It's actually your y-intercept. It's the starting value that they give you, especially when we're talking about word problems below. And b is going to be the multiplier, how it grows. Okay, does it triple? Does it double? But be careful that the variable x has to be the exponent. It could not be the base of the number. So like if you're looking at y equals x squared, that is not an exponential function. All exponential functions have x as the exponent. So we're going to look at this equation below. Y equals 4 times 3 to the x. And I know that the 4 is the y-intercept. It's actually your starting value. And the 3 is the multiplier. It's tripling, okay? So multiplier. And the x obviously is the exponent. Now we're going to make a table of values. So I start with -2, -1, 0, 1, and 2. And why do I do that? I kind of want numbers just really close to the origin because these get really big and really small, and it's hard to graph them when you get such large numbers. So we are going to plug in the x value as the exponent. So 4 times -3 to the, 4 times 3 to the -2, 4 times 3 to the -1, 4 times 3 to the 0, and we're going to put these all in our calculator. 4 times 3 to the 1, and 4 times 3 squared. Now you are going to get decimals. You can convert them to fractions, of course, if you hit, I believe it's math enter. I don't have the calculator in front of me. I'm going to pull over Desmos, and I've already typed these in, so you don't have to watch me type them in. But 4 times 3 to the -2 is 4/9. If you get it on your calculator, you're going to get a 0.44 repeating. We've got 4/3. We've got a 4, then 12, and then 36. So if we took these as ordered pairs, we would plot them, and you would get the graph to the right. Okay, notice that it's being multiplied by 3. It's growing by 3. Okay, it's kind of hard to see with the fractions, but the upper numbers, you can kind of tell that. Let's do a word problem. It kind of makes more sense when we talk about growth in a bank account. So we're depositing $300 in an account, and it pays 5% interest yearly. So your starting value is $300, right? Your multiplier is 5%, but you're not just multiplying by 5%. We're going to do this. It's 100% plus 5%, right? Because you keep what you have, and you're getting an extra 5%. So that's actually 105%, which then the multiplier would be 1.05. You always move a percentage 2 points to the left, 2 decimals to the left, and you'll have 1.05. So they want us to write an exponential equation to represent this. So we know that this is how we want to write it. The A is your starting value, and your B is your multiplier. That is all. That's all they want you to do. And then, of course, once you have your equation, you're going to see what happens each year. So if I plug in a 0, right, we're going to take our Desmos back. If I plug in a 0, 300 times 1.05 to the 0, I get $300. That makes sense. After year 1, I make $315 total. I had 300, I made another 15. If I plug in a 2 for 2 years, $330.75. Year 3, $347.29. And year 4, $364.65. Okay, so that's a real life example. I didn't do any negatives because we don't have negative amount of time, so I only went from 0 to 4. Let's look at example 2. A population of 15 chipmunks are released into a forest, so obviously your starting value is 15. The population triples every year, so we're going to put a 3 for our multiplier. So we're just going to write the exponential equation. Instead of y equals a times b to the x, we're going to write y equals 15 times 3 to the x. Okay, and we're going to change our calculator to say 15 times 3 to the 0. Oops, to the 0 is 15. So year 0, right when you release the chipmunks, there's 15 of them. But the following year, you get 45 of them. The following year after that, 135. And this grows very quickly. 405 after year 3. And 1215 for year 4. So how many chipmunks will there be in 6 years? So obviously change the 4 to a 6. And that is a lot. 10,935. That's crazy. Let's do another one. We've got a boat for $38,000. And the boat depreciates. Depreciates means it goes down in value at a rate of 9% per year. So watch what we're going to do. 38,000 is our starting value. It's going down 9%. So it was at 100%, but it's going down 9%, which is 91%. So we're going to use that as 0.91. Okay. Write the equation. Instead of y equals ab to the x, we have 38,000 times 0.91 to the x. Let's pull that into our calculator. They don't take long to do. We're going to put it to the 0 power, and it's 38,000. So after, like right when you buy the boat, it's 38,000. After 1 year, it's worth $34,580. After 2 years, $31,467.80. After 3, $28,635.70. And after 4 years, it's only worth $26,058.49. Okay. So similar stuff, but you've got to look if it's increasing or decreasing. And then write what, or use what you know about exponential equations to write the equation of the graph shown. Now, we know the equation should look like this, right? Okay. The A value is your starting value, but remember I said it's your y-intercept, and I'm looking that the y-intercept is at 5, right? So I'm going to put a 5 here. And now I've got to figure out what is happening. Like, can I find another point that's nice? And I'm thinking I see this. So 1 year later, if we're talking about time, instead of a 5, it's now a 10. Right? And then 1 year after that, I'm looking kind of up here, and it looks to be, 2 at 19, it says. If that's a little off. But I'm seeing this from 5 to 10, and I'm going to say that that doubles. So I'm going to put a 2 to the x. Okay, kind of working it backwards, looking at the y-intercept and what happens in the graph, right? Actually, 2 is at 20. 2 is at 20. Let me get that one off of there. So you are going to complete the homework that I assigned and submit it to Google Classroom. Thank you.